Class, my name is Mr. Nichols and this is Bob, my teaching assistant. And today's lesson is going to be on Euclid's theorem and similar triangles. You should have received a study packet from last class and already pre-read the study packet and started some of the activities to get you familiarized with the current material that we're going to be studying today. And what I'm going to do is play a clip off YouTube created especially for this class, and while I'm doing that I'm going to be taking roll and collecting previous homework, okay? Alright, ready for roll? Bueller, Bueller, Bueller.
Hey Mary, how tall do you think that light bulb is?
I don't know. I wonder how we can measure it.
I don't know. I don't think I can reach all the way up there.
I don't think so either. Well,
Oh, look at that.
there are two shadows.
There are two shadows.
And it does look like it forms a 90-degree angle.
And you form a 90-degree
Here's
angle.
the shadow. Is there a way we can use similar triangles to figure out the height of the pole?
Well, I think so, because the sun comes down and creates a congruent angle with your head and the top of that pole.
So it would make the same angle over there as well.
That's right. So now we know angle, angle, angle. By that theorem.
Use proportions?
I think we could use proportions of
Let's try
similar triangles to figure this out.
Right.
I just happen to have a tape measure with me.
Perfect.
Can you measure this shadow right here?
Okay, now you're like,
And that is 290 centimeters. And now I can measure your shadow and your height. Okay. And we'll measure your shadow. Okay. Let's see, what was that now? Oh, you're right. 160 centimeters is your height. 50 centimeters is the length of your shadow. Now we have a nice proportion set up for our similar triangles. And we can figure that x over 290 centimeters represents the pole, 160 over 50 centimeters represents Mary, and now we can solve for x. Times 160 by 290 divided by 50, and we get 928 centimeters is the height of pole. Oh, that was kind of fun.
that was.
That's tall, 928 centimeters.
Not taller than me.
Not taller than me. Alright, let's get to class.
Okay.
Back class, I hope you enjoyed our YouTube video we created just for you. We can thank Stephen and Mary and myself as the cameraman, and wish Bob could have been there, but he doesn't get around too much. How many of you ever heard of the Euclid's theorem? Anybody know the basic principles? Can describe it to me? Sure, if two triangles are similar, their corresponding sides are proportional. For triangles, the sum of the measures of the three angles is always 180 degrees. Two triangles are similar if two angles of one triangle has the same measure as two angles of another. Have you ever had like an object that's too high that you were curious the height of? Maybe when you were real little, you and your parents or somebody else planted a tree and now it's just taller than your house and you're just really curious about how tall it is? Well, today that's what we're going to learn. How many businesses do you think or hobbies do you think that would use this kind of activity, that would need to know something that's real high? Yeah, somebody that does rock climbing, wants to climb a mountain, they want to know how tall it is, but until they get to the top, they really don't know how tall it is. Or in architecture, or bridge making, things like that. Bungee jumping, that's a great one, bungee jumping. Yeah, you need to know how long the little thing is over there, don't you? Well, what we have for you right now is a pre-engagement activity to see if you read the material from the study guide. What we're going to do is it's a worksheet, and as you read the question on the worksheet, if you think it's correct, the statement is correct, you put a check, and if you think it's incorrect, you put a minus. And you do that on the left-hand side. And after our lesson, we're going to get those worksheets back out, and then we're going to have what you think after the activity. And while we're doing that, I'm going to go ahead and play another YouTube segment to get you, pass the time a little bit quicker. It'll be a video clip that I created for this lesson on indirect measures and proportions and similar triangles. How tall is Jill's tree? Introduction to similar triangles and indirect measures. Jill planted a tree when she was younger. She is now curious about the height of the tree. Since the tree is too tall for Jill to directly measure, she will use her knowledge of proportions to indirectly measure the height of the tree. Jill will do this by using shadows of the tree and her. An indirect measure is the use of knowledge of proportions to indirectly estimate the height of an object. The tree, Jill, and the shadows can be separated into two similar triangles. Assuming the ground is flat and level, both the tree and Jill are perpendicular to the ground. The angle of the sun's light is congruent for both Jill and the tree. Thus, the triangles are similar. A similar triangle is where the length of the corresponding sides of a triangle are similar, or the angles of the corresponding triangles are similar. Congruent angles are angles having the same size and shape. The height of Jill, Hj, and the length of Jill's shadow, Sj, are proportional to the height of the tree, Ht, and the length of the tree's shadow, St. We record the relationship in a ratio box. Proportional is defined as properly related in size or degree or other measurable characteristics. How did Jill perform the calculation? She used the principle of ratios. A ratio is a comparison of two numbers by division. Knowing her height of 5 feet, she may have estimated the length of her shadow at 6 feet and the length of the shadow of the tree at 30 feet. She then could solve the proportion in which the dimensions are feet. She has 5 feet over Ht equaling 6 feet over 30 feet. Using cross multiplication, she can find the height of the tree. By using indirect measures, we have found the height of the tree to be about 25 feet tall. This concludes our lesson on indirect measures and similar triangles. Thank you. Everybody finished our little activity? Great. All right, who can tell me what are some of the theorems used to find congruent triangles? Anyone? 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 Great. Angle, angle, side. Anyone else? Anyone? Anyone? Great. Side, angle, side. Anyone else? Anyone? Anyone? Great. Side, side, side. Anybody know what congruent means? Correct. Great. Now what I'm going to do is show you a little bit of this stuff in action here. Say you have this tall tree that you planted when you were real young, and you don't know how tall it is. Let's make a... Sorry, I don't have green, so I have to do a black tree. So you got this tall tree here. And here's this little guy here that wants to know how tall this tree is. We'll call him Jimmy. Jimmy wants to know how tall the tree is. Well, right up here, it's about, say, 3 or 4 o'clock in the afternoon. The sun's shining bright, and we got a red sun here because it's a whole lot hotter. So the sun is casting out a shadow. It's a tree. And Jimmy also casts out a shadow too. We just got to make sure Jimmy's not hidden behind the shadow of the tree though, so he can see his own shadow. Well, the sun hits the tree and Jimmy at the same angle. So we got these angles right here that are congruent. And right here, since we're on a flat surface, we got ourselves a right angle. And since the angles of a triangle equal 180 degrees, this right here is congruent to each other. So what Jimmy does, Jimmy goes and he measures the tree's shadow. Well, the tree's shadow goes out 24 feet. Now, we go and measure Jimmy's shadow. Jimmy's shadow goes out 6 feet. Jimmy's still kind of young, so he's a little bit small. He's only 3 feet tall. So right now we have a proportion. We have C, which is proportional to C, and as we have it right here, we've got 24 feet, 6 feet. And we know Jimmy is A. We want to find A prime. In principal proportions, does anybody know what to do next? Great, we could cross multiply, or we can cross multiply. You go 24 times 3 equals 72, and then divide it by 6 equals 12. We could do it that way, or what can we do to this little fraction right here? We could reduce it, yeah. If we just, what's half of 6? 3. So we know we can turn that 6 into a 3. And if this divides by half, what do we do with that one? Right, divide that one by half too, 12. So we got 3 over A prime equals 3 over 12. That makes it real easy. We know A prime equals 12. So we've got some other activities here. We have some triangles that we can do. Put 2 triangles on the board here. Okay, what are the corresponding sides of these triangles here? I know I did a bad job drawing and they almost look the same, but pretend that this one's just a little bit smaller for me. Alright, what sides are corresponding with each other from here to here? That's correct. AB and DE. 2 more sides. Good. BC, E, F. Is there one more? Great. AC and DF. Okay, right now we'll just say this is 26 inches and this side is 24 inches and this side is 10 inches. Alright, this side will be, we'll say 13 inches. Okay, what is the length of side DF? Which is side DS. So we need to find this right here. It's a little bit different than what's going on over here because we have this, but we don't have this. So can anybody tell me what to put on the board first? Okay, what we know. We know 26. That's correct. That's right, we know 13. And we want to find out that we know that one. That one's 10. So now what we do, we have all the tools that we need to find DF. So we'll get our trusty calculator out, the TI-89. And we go 13, multiply it by 10, which equals 130, and divide that by 26. We have a total of 5 inches. So this is 5 inches. It kind of stands to reason that this is half of this, and this would be half also. Okay, and just a little review. We've got the area of, how do we find the area of this triangle? Anybody know the formula for finding the area of a triangle? Great. 1/2 times base times height, which is 1/2 times the base, which is 10, times the height, which is 24. So we'll get out our TI-89 again. Excuse me, 120. Okay, now, anybody remember the Pythagorean theorem? We can use the Pythagorean theorem to find out this side right here, or we could use the principle of similar triangles. Which would y'all rather do? We'll go ahead and use the principle of similar triangles since we're already here. All right, we know 10, and we know 5, we know 24. What do we need to find right there? How do we find that? Multiply 5 times 24 and divide it by 10. 5 times 24 equals 120 divided by 10 equals 12. So this side is 12 inches. Now we can find the area of that. You got the base, which is 5 inches. You've got the height, which is 12 inches. Multiply it times 1/2. And let's see what we come up with now. $30. What do y'all think? Y'all, there's different ways to find different solutions, and also we could find out, say if we didn't know this 12 here, we could also use the Pythagorean theorem, do a little bit of review here. Anybody remember what the Pythagorean theorem is? Yep. A squared plus B squared equals C squared. Alright, we know A squared is 5. Or excuse me, yeah, A squared will be equal to 5 squared plus B squared. We don't know B squared, where we pretend we don't know that that's a 12, so plus B squared equals C squared, which is 13 squared. And that comes out to 25 plus B squared equals 169. We subtract 25 from both sides. B squared equals 144. Anybody remember their times table? I don't want to see any calculators. Anybody remember their times table? Great, so what squared equals 144? 12. Now what we have for you is another activity. It's a paper folding activity that we're going to do that'll kind of give you some more examples of similar triangles and proportions. Okay, each group has one of 3 types of paper. an 8 by 11, an 8 by 14, or an 8 by 8. And you also, each group has a protractor and a ruler. Now, according to the instructions here, randomly choose a point along the top edge and fold the paper so the bottom right-hand corner touches this point and label it as shown. Okay? And then what you do next is identify any congruent shapes, explain how to use these shapes, or how these shapes are congruent, identify any pairs of triangles that you think are similar, use angles and side lengths to prove or disprove your conjecture, compare your results with the other members of your group, and what do you notice? If you fold the paper to a different point, X, along EF, what do you think will still have the same pair of similar triangles? Explain why or why not. Check with 2 other points and compare results with the other members of your group. So go ahead and give that a try, and I will walk around the room and kind of supervise, make sure everything's going okay. If you have any questions, feel free to raise your hand. I'll come by and have fun doing that for you. Great. Y'all learned a lot from that. All right, here's some error patterns, some things that you might want to be taken care of when you're measuring, just to make sure you just keep in mind so you don't, when you're successful about performing this activity. The first is the incorrect use of technology. If you don't have the proper tools, if you don't have the proper measuring, if your calculator doesn't work right, things like that. The conversion of measurements. If you have a meter stick and you want to measure in inches, or if you have a yardstick and you want to measure in centimeters, you got to make sure you get it converted properly. And just simple mathematical computations. Instead, you could put like the 26, you could do 13 times 10. Instead of doing 10, you do 1, so it's 13 divided by 26 will be wrong. Or also another error in mathematical computations, if you don't match up your proportions right, you could put, say for example, the 13 on the top and the 26 on the bottom, where the 13 would then be matching to the 10 instead of to the 26. Just simple things like that to help just the process to go a little bit quicker, and you don't make just simple mistakes that anybody can make. A lot of times when I'm doing high-end calculus problems, just the simple arithmetic just nails me every time. Just a simple sign change, which all these are positive integers, so you don't have to worry about that. But just simple mathematics can give you a glitch too. And for homework, we need to finish completing the study guide, and we already did the paper folding activity, and we're going to do the little assessment sheet, at the after lesson reading for worksheet, where you did the plus and minus, if you agreed or disagreed. We're going to go ahead and get that done since it's after the lesson now, to see if you agree or disagree to the statements. And tomorrow, first thing, we'll be having a quiz on the chapter, on the material after you finish the study guide, review it. If you read the study guide real good, do a few of the practice examples, you'll do great on the quiz. So I appreciate y'all being here, and have a great day. Thank you.